Okay, thanks so much, Peter. Thank you so much for having me, and thank you everyone for being here. It's really great to see a number of familiar faces and some new faces. So yeah, thank you very much. So I'm Kristy Robinson. I'm an assistant professor in the Department of Educational and Counseling Psychology at McGill University. I'm the director of MILES Lab, which stands for Motivation, Identity, Learning, and Education in STEM Lab. What I'm going to talk to you about today is, as you can see from the title here, but basically we often think of motivation as something that students have or they don't have, and as something they're really responsible for maintaining themselves. In reality, classrooms provide many opportunities for students to become motivated, to stay motivated, or to lose their motivation. And as a result, students' motivational beliefs can change quite a bit, even in the short term. And these changes have important implications for their success. So what works for one student also might have the opposite effect for another, or might do nothing. So in this presentation, I'll highlight some takeaways from my research on university students' motivational experiences in large introductory STEM courses. I'll warn you too that throughout, or at least in a few places, I've got QR codes where you can kind of scan those and get a little additional information or full papers or things like that. And I'm always happy to provide additional info should you have questions. So in today's presentations, I'm going to start with some key propositions and some background for what it is that I study. We'll dive into motivational changes, like how motivation typically changes, who experiences changes, and why those changes are important. We'll talk about supporting students' motivation. So what are some strategies for doing that? And how do students perceive that? And how is that different or similar to what's actually going on in the classroom? And then we'll end with some takeaways, future directions, and conclusions. So let's start with some key propositions and background, which I'll start with a vignette to illustrate what I'm interested in. So here we have an instructor teaching a large chemistry course. This is not an unfamiliar sight for those of you who've been around higher education at all. Let's say the instructor is explaining a chemistry concept and he's noticing students are starting to look bored. So the instructor quickly thinks through their prior teaching experiences, their ideas about what could and should work in this situation, and they decide on a strategy. So the instructor thinks, okay, these students are starting to look bored, I'll tell an interesting story. So they tell their story, they launch into the story. Let me tell you about a time when I used this concept we're learning about to solve a problem in my life. And students react. In the ideal version of this story, what we would hope to happen, everyone in the class becomes interested again, right? Students all realize together, wow, I never realized chemistry could be used in this way. That's so cool. But as anyone who has ever taught or taken or observed a class knows, different students react in different ways. So some students might have a different reaction. They'll be like, oh, that doesn't really apply to me. You'll have other students who might not have even heard the story. You might have other students who are really still focusing on taking in the material and understanding the concept. So that story won't hit everyone in the same way. This is kind of common sense. But shockingly, psychologists haven't addressed this phenomena much in our work. We're used to looking at averages, right? How using a story, using an intervention, using a strategy can raise the overall mean, but that's not always how things work in the real world. So what I've been working on and learning and the work I've been doing in the past 10 years or so has led me to some propositions that I want to walk you through briefly. And that story I just told you illustrates some of this. So let's start with what teachers do. Teachers do things that they think will be good for their students' motivation. Things like being encouraging, telling interesting stories, or telling students why what they're learning is important. And again, in the simplest version of that story, things that teachers do in the classroom are a shared collective experience. So students all see that behavior, they recognize it as being supportive, and this leads to the class having a certain climate, right? So students are thinking things like, okay, we all agree that this is a friendly space, an encouraging space. And actually there is good evidence that this does exist. That climate is then providing all students with opportunities to be really motivated, to succeed. And this is how psychologists have typically studied motivational support. We look at averages, we maybe look at some interactions or some subgroup effects, but it doesn't always work this way. This is not always how this story plays out. So when we encounter failures to replicate our interventions or our ideas about how teachers can support students, or the means or the subgroups don't respond as we expected, we can get a bit confused, a bit befuddled. What I saw as an example of this is a great piece from 2016, Journal of Educational Psychology. These authors discuss how interventions show selective effects, inconsistent effects, and they argue, as you can see here in the highlighted portion, the grand challenge for the field is to develop better instrumentation that can capture relevant behaviors and attitudes over time and how these vary across contexts and population. So when I first read this, I was like, great, this is the solution. I took up that challenge with gusto. Okay, let's measure this better, and then certainly we'll be able to detect effects better. But that's when the sweater really started to unravel for me, because it turns out the way that we measure things, the way that we assess, the way that we research them really reflects our theories about how they work. And there wasn't a lot of theory about this exact phenomena that I've been telling you about, this heterogeneity. So something that has really stuck in my mind from a few years ago here was this piece on heterogeneity, and in particular, the need to build better, more robust, and complete theories that more accurately reflect lived experiences and that can be tested systematically in pursuit of targeted, accurate recommendations for policy and practice. So that's what I'm trying to do. That's what we're trying to build here, right? So let's come back to this diagram. The teacher does something, the whole class thinks about it, right? Or they react to it. Notice I've changed something here. I've added students, because students actually turn out to be an important part of the support and an important part of the climate too. And in reality, as we know, teachers and students do not enter the classroom as blank slates. They have beliefs, they have prior experiences, they have characteristics that inform what they do and how they interpret everything that happens in the classroom. So everything that actually happens is filtered through students' attention, or lack thereof, and the lens that they bring. So a climate is not just an objective thing, but it's rather composed of psychological representations of what's happening. So if a teacher demonstrates the importance of course content using real-world examples that really only reflect the values and norms of their own culture, then students who share that cultural background will likely interpret those examples as being more relevant to their lives and thus more motivational compared to students who do not share the teacher's cultural background, for example. And it's also not a simple unidirectional process. The instructors and students in the course are all influencing each other. They're all behaving, they're all doing things. So something great that the instructor does may or may not have a certain impact on the climate based on what the students are also doing and how they're viewing that. So the climate is emergent from dynamic support systems that are enacted and reacted to by all members of the context. So all that means we not only have a collective motivational climate, right, what the whole class thinks collectively, but we also have heterogeneity in how students think about the class. And actually both climates and what I'm calling microclimates play important roles in students' outcomes, like motivation, like major choices, career choices, achievement, things like that. And those outcomes of climate and microclimate then kind of cyclically become the characteristics we talk about as informing students and teachers' behavior and the lens that they bring to the classroom. All this is cyclical. So what does that mean for practice? First of all, it means that when instructors are successful at supporting students' motivation, it means they're navigating a very complex set of factors. They're quickly processing student inputs, they're coming up with great solutions on the fly, and they're probably pretty in sync with what their students need and how to meet those needs. Another takeaway here is that I might have the absolute best toolkit of teaching practices and use them in ways that on paper should work extremely well, but I can't know they're effective for sure until I see how students perceive and respond to those practices. So in other words, a motivationally supportive teaching practice can't actually be motivationally supportive if students don't notice it, if they don't perceive it that way, or if they don't need it at the time that I'm giving it. So that's my little crash course on the theory I'm proposing. That we're just skimming the surface there. I'm very thrilled to say that this was all described in depth, including where these propositions are coming from, what's the research that's backing up these claims, and where do we need more research to test these claims. in this paper that was published just barely, seriously, 2 weeks ago, in Educational Psychologists. And that QR code will take you to the full paper. Thank you, Peter. That's nice. So that background, with that kind of theoretical background, you can see where my mind has been at for the past few years. And you might be able to anticipate some of the thorny questions we've been grappling with in my lab as we try to develop our understanding of how can classrooms and instructors best support students' motivation and engagement. So I'll show you how I've been building these propositions and tackling some of these thorny questions in my own work. But let's talk about the broader background first. So I study motivation and motivational climate in science, technology, engineering, and math fields. And this is because students in STEM often face challenges to maintaining high motivation due to competitive milieu, perceived difficulty, and identity threats often present in these courses, right? Students tend to think of these courses as being really hard and as being competitive, things like that. And indeed, prior research documents average declines in student STEM motivation across multiple time periods and multiple contexts, suggesting that we really need to understand how to better support students' motivation in STEM and really provide opportunities for students to become and stay motivated. So in addition, we have good reason to suspect that STEM contexts may differ in how well they support students of different backgrounds and life experiences. So it's not just the average experience we should consider, but also how different students experience the same STEM instruction. So thinking even more broadly, STEM education is really important for healthy communities. Canada continues to lag behind other countries in our STEM workforce and innovations. And an area of particular concern is how certain STEM fields fail to reflect the broader population with regard to gender, race, and ethnicity. And this is problematic for economic reasons, economic mobility reasons, right, as STEM careers are among the most lucrative. And it's particularly problematic when we consider that diversity can be a real driver for innovation, and especially for ensuring innovations serve the communities that need them most. So as an example, Statistics Canada shows us that women are still underrepresented in STEM majors overall, and particularly in math-intensive STEM majors. I know this is a lot of information, but what this report published in 2021 shows us is that among all students enrolled in bachelor's degree programs, 24.2% of male bachelor's degree students enrolled in math-intensive STEM programs, and that compares with only 5.4% of their female counterparts. These representation issues are even worse when you compare men and women's STEM graduation rates, and then worse again when you look at their participation in STEM careers. The gaps get bigger at each stage. We see similar patterns across the US and Canada, suggesting STEM culture is similar. The STEM pursuit by race and ethnicity is a bit harder to get at in Canada, but data from the US show us really stark racial and ethnic representation issues in the STEM workforce, as an example. We do know that in the US and Canada, Black, Hispanic, Latine, and Indigenous folks pursue and attain STEM majors and careers at much lower rates compared to white and Asian people. So all that is to say, coming back to this original point, students opt out of STEM fields or fail to learn STEM content for a lot of reasons, including because they view it as too difficult, not worthwhile, too competitive, too discriminatory, and or not reflective of their identities and communities. And ultimately, these are motivation issues, not just motivation with individuals, but in how contexts shape motivation. So if we want to provide maximum opportunities for students to meet their valued goals, we need to make sure their motivational needs are met as much as possible, and that requires knowledge about what they need and how to meet those needs. So something important that we need to establish is, what do I mean when I say motivation? So this is the definition that we use in my field. Motivation is the process of initiating and sustaining goal-directed behavior, and motivation also influences the quality of behavior. So if success is flying a plane to a desired destination, think of motivation as the engines providing the power necessary to get you in the air and keep you there. So you can think of a time right now when you felt really motivated or not motivated to engage in a difficult task. Why did you start working on it? Why did you keep doing it? What strategies did you use and why? You can probably think of a variety of beliefs and mindsets that really sustained you in that task, or that you were missing for something that you weren't very motivated about. One common misconception about motivation is that it's one thing. Motivation is not just one thing. It's made up of many different beliefs and thought processes that work together to energize you. You can think of these as being like the many different parts that enable the plane engine to function. So motivation, we can put these beliefs into two broad buckets that are based on individuals' beliefs about, can I do this and why do I want to do this? We really need good answers to both of these questions in order to do our best on a task. Now, if you saw my colleague John Ranalucci's talk a while back, which I highly recommend watching the recording on YouTube, he explains the theoretical origins of these questions and this framework for thinking about motivation really well, so I won't repeat that here. So one last piece we need to talk about is, why is motivation important? Why do we need good answers to these questions? Well, we do need motivation for our engagement and persistence. There's a lot of research that shows students' motivation is an essential ingredient in getting them to engage and persist on difficult tasks, and getting them to use higher order strategies rather than surface learning strategies for their learning and achievement, for their emotional well-being, and for their major and career choices, even the choice to take an advanced course earlier before post-secondary. And it's not just the quantity of motivation that matters, but the quality, right? So if my kids only make their beds every morning because I make them do it, I want them to, this is not likely to be a behavior that persists beyond the time when they live in my house. And it's not likely that they'll take a lot of time and effort. All right, so moving into motivational changes. I want to start framing this section with something we're all familiar with, I think. We often start out the academic year, the semester, with grand ambitions that tend to wane as reality hits a little bit. This is a motivational phenomenon, something I wanted to document more carefully so I could figure out, for example, what kinds of support do students actually need, when do they need it, and who needs it most. A whole bunch of studies show that indeed students' motivation tends to decline over time on average. I'll show you a specific example here. In this study, we asked engineering majors about their motivation at 3 different time points. First, just before they began their university studies, so like their first week on campus, we asked them to take a survey. Then again, near the end of their first year, and then again near the end of their second year of university. And this is reflecting their responses to questions about their expectancy for success in engineering. So their confidence that they'll succeed in their engineering major. With this, as you can see, started out pretty high just before beginning university, then significantly declined over time on average. So for that important motivational question of, can I do this? Students got increasingly uncertain of their answer to that on average. We also looked at 3 types of value for engineering, and they also significantly declined over time. So students were tending to lose interest in engineering. They were thinking of engineering studies as being less and less useful for their goals, and they personally identified less and less with engineering as time went on. So think about the why do I want to do this motivational question. All of students' typical reasons for trying hard in their engineering courses all got more and more uncertain that they had strong reasons to pursue engineering. I shouldn't say all students, all values on average declined over time. And at the same time, 3 demotivating beliefs, 3 types of cost beliefs significantly increased over time. So these are answers to the question, why do I not want to do this? So students viewed their engineering studies as more and more costly to their other valued opportunities, to the amount of effort they had to put in to succeed, and to their psychological health. So taking these together, going the wrong way here. Taken together, on average, the trajectories show maladaptive patterns of development. And this corroborates a number of other studies looking at motivational beliefs in math and in language arts over several years of primary and secondary school, as well as studies looking at science students across 4 years of university and a few others. And these changes may look really small, but they have important consequences, as I'll show you in a moment. But first, you may be wondering, okay, if we think women and students from traditionally underrepresented racial and ethnic groups face extra barriers to success in STEM, and in engineering here in particular, then we'll see that show up in their motivation trajectories, right? Well, what we saw in this data really turned some of our expectations on their heads. So first of all, men and women didn't show any significant differences, either in the levels of the trajectories or their rates of change. Race and ethnicity and first-generation college student status also were not associated with differences in slopes, but very interesting results with respect to levels. So this is at time one, their intercept of essentially of that trajectory. Just before students began college, Black and Hispanic or Latine students and first-generation college students had significantly higher expectancy for success, higher interest value, and higher attainment value. So that's identification with engineering than white and Asian continuing generation students. And underrepresented minority students also had lower effort cost. So that's a maladaptive belief. So overall, they're having sort of better motivational levels at the beginning. Note again that these mean differences appear small in magnitude, but keep in mind this is controlling for prior achievement and for gender as well. So in other words, students that from STEM representation data we would expect to be struggling with their motivation actually are coming into university extra motivated with higher quality motivation compared to their traditionally overrepresented peers. So I told you I'd talk about outcomes too. So students with slower declines in expectancy and value and slower increases in cost beliefs actually achieved higher grades, their cumulative grade point averages in their engineering courses, and were more likely to remain in engineering major. And taking a supportive gateway course in the first year as compared to taking it later had a stabilizing effect on some of these positively motivating beliefs. So essentially, those who took the course in their first semester as recommended received a motivational benefit compared to those who took the course later, even controlling for different levels of preparation. So what I took this to mean is experiences do seem to make a difference. So this is across 2 years, right? These are 2-year trajectories. How much can one course, even like one semester, really change students' motivational beliefs? If these changes look pretty small, you might or may not be surprised to learn that we see similar patterns in the short term. Students' motivation shows maladaptive average declines and increases even in a single semester. And these changes then predict their achievement and their likelihood of continuing in their field of study. The good news is that in courses where instructors really care about teaching and really attend to these processes, we've actually seen more flat or even positive trajectories, even when they're teaching remotely due to the pandemic. So a brief note about these trajectories is that they're showing means, right? So you have to imagine that if we could map every individual student trajectory on this graph, it would look very chaotic, right? These mean trajectories aren't necessarily where any one student's experience lies, right? So when we use a statistical technique called mixture modeling, we can start to identify subgroups in the data that have qualitatively and quantitatively different patterns of change. So let's take a look. Let me show you what some of those subgroups can look like, focusing first on a course that I would consider to be quite typical as an introductory STEM course. This is a general chemistry course in fall of 2016 at a large Midwestern university in the United States. Large lecture course, like is depicted here. We took 3 measurements of attainment value. This is identity-related importance. So how much students identified with chemistry as being really important to who they are. And we use growth mixture modeling, which identifies subgroups of students that are defined by different change patterns. What we found here are 3 different groups. So the first group here, high and stable, 54% of students came in really strongly identifying with chemistry and stayed that way throughout the semester. 41% of students had significantly lower attainment value, but they increased a little bit throughout the semester, which is very interesting. And just a small subgroup, 6% of students came in with slightly lower attainment value and declined rather dramatically throughout the semester. So this finding suggests the average declines that we've seen in study after study in various age groups and timeframes may in some cases reflect only a smaller subgroup of students. They could be the ones kind of pulling that trajectory down on average. So it's important to remember that declines aren't inevitable, right? And interestingly, in this sample, we saw no gender differences, and race and ethnicity also was not associated with lower or higher probabilities of being in that moderate, and declining trajectory, which is what we would probably consider typically to be our risk trajectory. And in fact, let me show you more of what I think is a success story of what those subgroups can look like. Focusing on some courses where we know the instructors are very good at motivating students. They use a lot of motivationally supportive practices. These are instructors that were purposefully selected because they're interested in teaching and they're interested in this. We've worked with them for several semesters. Now, this was even before we started working with them. This was our first semester in fall 2019. Let me show you what we found here. So we have 4 different groups here. We're looking at both expectancy for success, so confidence, and attainment value together. In these courses, there's just 2 courses. 11% of students were classified as increasingly confident chemists. They had fairly low confidence that actually increased throughout the semester, and they had moderately high and stable identification with chemistry. Now, another 11% of students were classified as moderately confident chemists. They had similarly high and fairly stable identification with chemistry, along with moderate levels of confidence that they could succeed in chemistry. Now, the third and largest group had levels of both confidence and attainment value that were remarkably high and stable, suggesting the majority of students had high quality motivation throughout the semester. And lastly, 15% of students were confident throughout the semester, but did not really identify with chemistry. In fact, they appeared to disidentify with chemistry more and more throughout the semester. So as you might expect, the high and stable confident chemists had the highest grades in the course and had the highest intentions to pursue a chemistry-related major. Now, interestingly here too, women were most likely to be in classes with lower expectancy for success. So they tended to be in groups with the lower confidence trajectory, and men tended to be in groups with a higher confidence trajectory. So what we're learning here is we can use techniques like mixture modeling to narrow in on students who are doing just fine with their motivation and students who might need some extra motivational support. So some takeaways from the motivation trajectories results. First, we do see that average declines are quite common, even in the short term, but looking just at the averages can mask some important heterogeneity in students' developmental patterns. So in other words, declines are not inevitable, right? Not everyone is experiencing declines, and we can actually make a class that is supportive to where most students are not experiencing declines. So supportive experiences can make a difference. So let's talk about how. How do we support students' motivation? How are students perceiving this? And then what's actually happening? I'd love to know first briefly what you think about this. Thinking about your own experience as an instructor or student or both. What's a word or phrase that describes very motivating instruction? This could be a quality of the instructor, something about the activity. Feel free to drop it in the chat function here in Zoom. It could be something about other people in the environment. I'll pause for a moment here and see what you think about motivating instruction. Pre-planning, but also quick thinking. So superheroes, excellent. Interesting, passionate, engaging, vital, wonderful. Great, and continue to add to this. Feel free to, if you think of more. Absolutely. I think what you're saying aligns really well with what motivation researchers and theorists would say. So if you ask a motivation researcher, how can I support my students' motivation? You'll probably hear one or more of these general principles. These were principles distilled from decades of motivation research, cutting across all the major theoretical perspectives and the work that's been done to really identify the points of overlap and where the strongest evidence lies in motivation research. So the main strategies to use, and these are just principles, right? Supporting students' actual competence, right, as well as their confidence, their feeling that they're competent, enhancing students' opportunities to use their autonomy, making sure instruction is personally relevant to students, providing opportunities for active involvement, focusing on growth and mastery of the content rather than on social comparisons or on performance, and fostering belonging both between student and teacher and among students in the classroom as well. So this is a really great framework for thinking about motivational support done by both Lisa Lynn and Ray Garcia and her colleagues, as well as Julianne Turner and her colleagues. I definitely encourage a read of those papers there that are referenced. So to give you some evidence of the effectiveness of at least two of these principles, I want to come back to this slide we saw earlier, right? These four trajectory groups. So students who perceive their instructor as making more connections between course content and real life were less likely to be confident non-chemists compared to the other three groups. So that means students who perceive their instruction, the instruction in class, as being more relevant were more likely to identify as chemists. And perceived instructor warmth and enthusiasm appeared to distinguish groups with higher or increasing expectancy for success versus lower. So students who perceive their instructor as being more personable, more enthusiastic, were more likely to be classified in more confident groups. So, but notice how I phrased that finding. Students who perceived their instructor a certain way. And remember that these results were taken from just 2 classes. So students in theory are actually sitting in the same situation, right? But they're kind of all over the map in how they report their instructor's relevance, their instructor's enthusiasm and warmth. These are large lecture courses too. So places where students aren't interacting one-on-one with the instructor too much, but they're sitting in a large lecture hall, largely receiving the same exact instructor messages and supports. And yet we still see these heterogeneous trajectories, and students' perceptions of instructors are also quite heterogeneous. Like this, right? To illustrate more concretely, here's some data from just one course. This is actually from 2022, but our data always look like this. In the black, you can see means of students' perceptions of the extent to which their instructor related course material to real life. We have a few questions about this. For each student, we take a mean of a few questions about this. Time 2, time 3, and time 4 each represent different times of the semester for the same course. So the black is the means for the class overall, and the colored dots represent individual students' rating. So each red dot, green dot, or blue dot is one student's rating. And what you can see is that they're all over the map, right? In time 2 here in red, you can see some students strongly agree that their instructor relates course material to real life. Some students disagree, and then you have a whole bunch of students in between the two. And these perceptions are what's important, right? Remember the previous slide where we see perceptions differentiating students' motivational trajectories. And we see this over and over in the literature. Students' perceptions are much stronger and more consistent predictors of their outcomes compared to what teachers say they do or what researchers look and see teachers doing. So thinking back to the propositions that I introduced earlier, the black here is the climate, and the individual dots are microclimates. And in this case, those microclimates are really important for students' outcomes. So this raised a lot of curiosity for me and for my research group. How can we make sense of this? So we decided to do a little bit of an investigation. Right, we've seen these heterogeneous reports of what's going on in the classroom time and time again in our work and in other published studies. So it raised some questions we wanted to investigate, starting with some pretty basic investigations of students' demographic characteristics. Now we asked these questions in this way because we're keeping in mind the patterns of overrepresentation and underrepresentation in STEM, right? So we asked, do students in the same STEM course differ systematically in their perceptions of motivational climate based on their gender or their race and ethnicity? And then do those differences show up consistently across different STEM courses? So if we don't see too many motivational differences in motivation when students start their undergrad programs, perhaps the problem is with the environment, right? It could be that STEM classroom environment is unsupportive overall, or it could be that it differentially supports students from various groups. So in other words, we're asking, do STEM classrooms provide more opportunities for men and students from overrepresented racial and ethnic groups than they do for women and students from traditionally underrepresented racial and ethnic groups? So for this study, we went into 5 large introductory STEM courses. You can see how many students came from each of those courses and some demographic characteristics of our students. The sample was primarily East Asian and white. Students took surveys for course credit. They could opt into the study or take the surveys for course credit without participating in the study. And this all took place in fall 2020. So this is when classes were online and students were mostly watching lecture videos. So there were even less opportunities than normal for students to get actual differential treatment, right? So this allowed us to really hone in on perceptual differences rather than differences in how students were treated. Just some examples of the questions we asked students. We asked about 4 dimensions of motivational climate. So perceived autonomy support, instructor mastery goals, connections to real life, and the teacher is personable and enthusiastic. I'm going to skip right to the results here. In this data, Black, Hispanic, Latin, and Indigenous students reported lower connections to real life in organic chemistry and higher teacher enthusiasm in general chemistry, but those were the only differences we saw for race and ethnicity. There were no other differences across racial and ethnic groups in any of the courses or for any of the 4 climate dimensions. So mostly no differences for racial and ethnic groups. However, women reported higher motivational support for at least one motivational climate variable across all the courses, except in calculus, where they reported lower autonomy support. And it may or may not surprise you to know that calculus was the only one of these courses that had a male instructor. However, the other gender coefficients for calculus were not significant. So what does this mean? So we did find evidence that gender and racial and ethnic identities explain some of the variation in students' differential perceptions of their classroom. However, the gender and racial ethnic differences were largely opposite of what we would expect. And we think that the instructor's gender may be an important factor for supporting women's motivation in STEM in particular. And our takeaway from the study is that we think differences in perception are not going to be consistent across contexts and across groups, across students, but rather they're a combined product of the student and the situation. So let's skip to this part actually. So for our research questions, right? Do students in the same STEM course differ systematically? Yes, to some extent, but it depends on which class and which climate dimension. And are those student perceptions differences appearing consistently? No, they're really not. So we wanted to explore this more, taking a more exploratory approach. So we did. We brought students in, we asked them about their demographic backgrounds, their characteristics, and we asked them about their chemistry-related motivational beliefs. So how confident do you feel? What's your value for chemistry? What are the costs you associate with pursuing chemistry? We had them watch 2 videos that we selected, and then they rated their perceptions of the motivational support in the videos. They're very brief, like 1 to 2 minutes each. And then we interviewed them, asking them about their perceptions. Why did they answer the questions the way that they did? And how or why might different students respond differently to the videos? And the 2 videos were selected because we thought they were really motivationally supportive. They were good examples of motivational support. First video was the instructor contextualizing the day's topic, introducing the main messages, things that students needed to take away, and highlighting both specific ideas and misconceptions. And then the second video was really interesting. The instructor narrated a historical story about wine and chemistry and used that to tie in some of the main concepts from the day really dynamically and enthusiastically using diagrams and illustrations. So again, skipping straight to findings here, the students who already highly valued chemistry perceived more opportunities for active learning and for questions. So the students' incoming value for chemistry. And the more confident students perceived more communication about the usefulness of chemistry. So they're picking up on, okay, this is, the instructor is telling me this is useful. English language learners, so people for whom English was not their first language, received fewer opportunities for participation, for active learning, and for questions. And women actually indicated it was harder to pay attention to at least one of the videos. Now, importantly, these results were not the same for both videos, right? We had different results for different videos, suggesting different students attend and respond to different features of instructions. And in our interviews, we learned much more about some other factors beyond these and why these factors might shape their perceptions of instruction. There's a QR code, and I'm going to give a shout out to doctoral student Sanhita for her great work presenting this at AERA last week. So some climate perception takeaways. Students perceive the same environment differently. We've documented that pretty well. Students' personal characteristics can partially explain this, but not consistently and not systematically. And students' existing motivational beliefs seem to also be important for shaping their views of the context. So what we think here is match or mismatch between students' needs or preferences and the contextual affordances really seem to matter. Right? Students will say, yes, it's motivational. Others will say, no, it's not. It seems to be very complex. So you can see we've covered some parts of this model pretty well, right? We're unpacking attention and appraisal processes. We're linking climates and microclimates to important outcomes for students. But what about this middle part of the model, the motivational support part? How do we tell teachers what they should do if perception seems to be the most important thing? So we're not saying actual supports don't matter. In fact, supports matter a lot and can actually direct students' attention and appraisal. It's just that there's not a lot of work on this yet. It's really hard in research to connect actual supports with perceptions, with outcomes. Our methods are needing to catch up here. So in our work right now, we're focusing on linking support with perception, trying to come up with ways to look at supports really systematically. The idea here is to first document what's really going on in classrooms, what teachers are already doing, as a very important first preliminary step in considering how we might support or intervene or design to optimize students' opportunities. So in this section, I'll talk about what we've been seeing just briefly in lecture videos that instructors have very kindly provided access to. This is what we've been working on very recently, just these past few weeks. It's been a really interesting and rich exercise for us. And as a side benefit, we've learned a lot about chemistry and computer science and math. I also want to make sure everyone knows, again, that these instructors were specifically included in the study because of their interest in teaching. So this is not necessarily what we'd consider to be typical in these settings, although, of course, I hope it could be. So the first thing we looked for in our fall 2022 lectures was relevance statements. So this is when instructors are making connections between course content and something outside that immediate instructional context. So they might be connecting a concept to future lectures, to other education opportunities, to jobs, to current events, things like that. So for this one, I'm just going to start by showing you one course because we did quite a bit with this data. In this one course, we picked 4 different lectures chosen based on their timing just before we released the student surveys, right? Because we wanted to see how our views and students' views aligned. So these are lectures spread throughout the semester. So let's first pay attention to the overall number. You can see at the very beginning of the semester in September, we saw just one relevant statement in that lecture. But by the end of the semester, we're seeing quite a few. And in a moment, I'll show you some examples of what these were. And at first, as we were coding this video, we were only focused on counting the number of relevant statements per lecture and then characterizing what kind of relevant statements they were, right? Were they about work? Were they about future classes? But we quickly realized that there was a lot of variety in the quality of these statements. So low quality, as you can see in like the light gray, would be things like, okay, the midterm's coming up, you need to know this, versus high quality statements would be like telling a story about a Nobel Prize winner, stories of how the concepts were derived, why we need this in our everyday lives, things like that, really rich examples of relevance. So why it's important for students to be aware. So you can see we saw a lot of high quality, or at least a few high quality relevant statements in the middle of the semester, and kind of the distributions differed in the different lectures. So then if we compare that to students' perceptions of relevant statements, we do see that increase reflected to some extent, although it's perhaps not as dramatic as we see in our direct observations. So we wonder if instructors were seeing students start to flag a bit and were upping their motivational supports to try to buoy them, or if students somehow just become less responsive to relevant statements over time, or it could be something else. So as a comparison, I want to show you one other course that showed a different pattern. In this course number 4, we see the second lecture is where we saw the highest number of relevant statements, although we classified them as low quality because they were focused exclusively on what students needed to know for the midterm, right? And then we compare that to the yellow line on the right. You can see students in this course didn't really appear to perceive a lot of differences in relevance across time. So what this makes us think is that number and quality might be equally important. Quality might be more important. Just like in other motivationally supportive practices, we need to make sure we're tracking both. So here are some examples. I'm not going to read these out to you. What you can see is in the various courses we looked at, instructors are highlighting the relevance of the material by talking about what actually happens in real life, when they're going to need a certain strategy in the future, or in their work, in the professional world, or giving kind of analogies even. The hugs example at the bottom, illustrating how chemistry concepts work by giving sort of a bodily hug example. So a second thing we looked at was enthusiasm. This is when instructors are conveying positive and activating emotion about the course content or activities. There's really interesting literature on enthusiasm, suggesting it's contagious and can boost students' interest and even their confidence, as we've seen in our own prior work. So here I'm showing you this information in a different way. This is results for 6 different courses altogether. This is different lectures spread throughout the semester. Note that I didn't have or code video for all courses and time points here. So most of these that look like zeros are not true zeros. It's just that we didn't have that lecture for that course. What I want to highlight here is, the highest number of enthusiasm displays in a single lecture was around 12, as we see course number 3 here in lecture 4. And we saw a generally increasing pattern, although that pattern was not universal across all the courses. So think about course number 1 here in the red, and course number 6 here, kind of flat pattern. Again, comparing this to student perceptions, they're all on top of each other here, so I'm going to zoom in the y-axis on this next slide. Here's that same data I just showed you, just changing the y-axis. So note these are very minute differences. The takeaway here is that student perceptions appear to be relatively flat or even declining a little bit throughout the semester compared to our observations that show a general trend of increase or kind of ups and downs. Think about course 3 in the light gray. And on this measure, it's really important to note that for student reports, we see quite a bit of disagreement among students. We think that perhaps the culturally bound nature of emotional expression could have something to do with that. We also looked at rationales, but for sake of time, I'm going to skip over that part and give you some enthusiasm examples. So we're looking for tone of voice, we're looking for verbal exclamations, and times when they're talking about the course content as being exciting, interesting, or fun. We saw some examples of humor, too, that were also counted as enthusiasm. So in these findings, we've seen that what we came in with an assumption of teacher supports are important for shaping students' perceptions and outcomes, but it's not as straightforward as we like it to be, right? In these findings, we've seen some alignment between what we notice and what students notice. We've also seen some mismatch, alignment with relevance, mismatch with enthusiasm. So what we think here is that we really need to know what students are noticing, what they're remembering, what they're appraising as being supportive is what we need to identify and recommend. So I'll just give a brief shout out to our ongoing study, which is a think aloud study where we're asking students our typical survey questions and asking them to talk about what they're thinking, what they're relying on. What we're already finding from preliminary data is that students think of a lot of different things and not necessarily what we would expect. So if we want to change the motivational climate and we want to measure it, if we have an impact by changing something, we need to make sure our measures are accurately telling us what's happening, and we're not there yet. All right, so I know we're short on time, so let's get to takeaways, future directions, and conclusions. So in popular conceptualizations and in a lot of research, we have already really focused on motivation as a quality of the individual, right? You either have it or you don't. It's your responsibility to maintain it yourself. But newer conceptualizations of motivation acknowledge that it's a very social and contextually bound process. Yes, I'm motivated by who I am and what I bring to the table, but my context, my classroom, my assignments, my teacher, my classmates provide lots of opportunities for me to stay motivated, to become more motivated, or to lose my motivation. So why should we be focused on trying to support students' motivation? Because it can change, and a lot of those typical changes are not looking so good. So what we see from the research that we've been doing over the past few years is that average trajectories and average effects can really hide some important heterogeneity. And that all 3 of these, supports, climates, and microclimates, all matter. We really need to be looking at all 3 if we want to develop systematic understanding of how students' motivation develops in response to what's happening in their context. And what's good for one classroom, one student, or one moment can be ineffective for a different classroom, student, or moment. Supports are relative. And lastly, what students notice, remember, and appraise as being supportive is what we need to identify and recommend. And that's what we're trying to do in our current and future work. So our burning questions for future research is a stronger climate, what we think of maybe as consisting of more consistent and clear messages about what's important and valued better for students. Can we really unify the instructional message in a classroom, or alternately adapt microclimates to students' various needs and preferences? What are the most important impactful practices needed for providing equitable opportunities in STEM classrooms? So what's missing for various students whose needs are not being met? How can we optimize that a bit? And how do we do that? What about peers? We talk a lot about teachers, but peers play important roles, and we haven't integrated those too, because we know instructors are responding to what students are doing. It's not just unilateral actions on the part of the teacher. And then how do we build a better sort of pipeline for making changes? My goal is really to come up with an efficient set of steps or guidelines for quickly and accurately assessing what's going on already in a particular context, then selecting and adapting a suitable approach for boosting students' motivation, then quickly figuring out if it's working and iterating again. Because teachers are already doing things that support or unintentionally undermine students' motivation. We're not going into neutral spaces here. So figuring out what's already going on there is probably the most important step in designing motivational supports for students in a particular context. And a lot of times the way we've done this as psychologists, going directly to students, giving them kind of an inoculation type intervention, is that just buffering them against these sort of inherently unmotivating contexts? And can we actually just change the context in the first place? I do think that effective motivationally supportive teaching does not have to be an extra to-do list item on teachers' list. They have a long list of things to do. It should actually make their jobs and students' jobs easier. So it really can be just in how you teach, how you deliver your normal instruction. Because, and this is really important, because motivational supports and the lack thereof, like access to motivational instruction can, or the lack thereof, can really perpetuate inequities. Lastly here, what I think this means for teachers and for us as researchers is frequent small-scale student perception data, whether that's formal or informal, right? Look at your students and see what they're experiencing, can help a lot in designing and adapting effective motivational supports. And that means asking students the right questions in the right ways can help us get a more accurate and actionable set of insights. So I want to say thank you to my lab members who are pictured here, as well as my collaborators, and funders who have supported my work thus far. And I'm so sorry for going right up until 12:58, trying to do too much in one talk. But thank you so much.